Well, okay. Thank you for having me again in this GroupBy virtual summit, the best virtual summit ever. Always happy to deliver sessions here. I don't recall if it's my second and third time, I think. But regardless, it's always good to be here. I love this conference. Today, I'll be delivering a session called Database DevOps for Leaders. So this session is part of a series I have. The series is called CI and CD with SSDT. This specific session is a sort of, I guess you could call it an introductory session, basically focusing on the motivations and ROI and reasons for or against database DevOps implementation in an organization. So before we dive in, a few words about myself. My name is Eitan Blumin. I'm a DBA team leader and senior consultant at Madeira Data Solutions. We are the leading consulting company in Israel for the Microsoft Data Platform. We are also very active in the local community, local and international. I have a blog on my official website where I publish all kinds of stuff. And I also co-host the SQL Server Radio podcast together with Guy Glanzer, the CEO of Madeira Data Solutions. You can also find me on Twitter, LinkedIn, and so on. What else? I'm an MVP, Microsoft MVP in the data platform field since 2020. I got a few certificates, not so interesting. So anyways, I'll move on. Okay, about this session. As I said, it's a sort of introductory session to the field of database DevOps. It I would also talk about DevOps in general, and also focus on database DevOps specifically. I will talk about what it is, what it's for, the challenges, advantages, ROI, and some management level best practices. The target audience of this session is anyone at C-level positions, such as CEOs, CTOs, CIOs, and team leaders, and maybe project leaders, project managers, sorry. Right, so with that introduction out of the way, let's dive in and see what we are going to have specifically on the agenda. We're going to talk about the purpose of DevOps, what is DevOps in general, what is database DevOps specifically, what are the challenges, ROI, as I said, and ways or best practices rather of implementing database DevOps. We're going to start with the purpose of DevOps. So this is very high level conceptual sort of thing, right? So the purpose conceptually of DevOps is to work, I guess you could say, in agile form, which in practical terms means that we are moving from working individually as individuals or as isolated teams in separate silos to working as a team with cross-disciplinary members in the same team working together cohesively. That's one. And two is moving from big and infrequent and difficult deployments or releases to small and frequent and easier deployments or releases. These two, let's call it paradigm shifts, would eventually lead to one, fewer production errors, and I'm talking about specifically errors in production, and also not less important is faster time to market. I don't think I need to stress enough how important this is for a business and what are the benefits of having these advantages um, in your business, in your system. I'm certain most, if not all of you, are familiar with some kind of version of this infinity sign diagram of DevOps in general. Essentially means it's a sort of cycle that feeds itself infinitely. Specifically, we're talking about building something, as in coding, programming something, and then building it. Whatever it is that we built, we test it, and then as considering that, assuming that the test is successful, we release it to various environments um, and deploy the new version. We operate the new version once it's in production, and we monitor it, and then the cycle fits back on itself when we plan to improve and add on top of the existing version, leading us into the next version. And the cycle repeats. This is very high level conceptually. What I personally like to identify at an organization to answer the question whether the organization actually does implement this DevOps methodology is when I ask the question what sort of tools or platforms the organization is using. Specifically, I'm talking about things like some kind of task management system, such as Asana, Monday, Azure DevOps, Jira, whatever it is, doesn't matter which one, but something that is used for managing the work items and the projects and the smaller, more granular levels of the projects, as in specific tasks and features and work items and so on. We would have a cross-disciplinary team working with these work items. And that would mean things like, for example, we have, let's say like an epic or a story, or like a high-level mission or task given by the product manager, for example, and then that will be that same item is handed off to, let's say, a team leader, and then those distribute sub work items, let's call it that, to individual developers. And then when each developer finishes their specific task, then it goes on to QA. And so the same tasks, basically, they travel between team members based on the development phase that they're in. Next, we would have source control of some kind. Doesn't matter which one. There's all kinds. You have GitHub, GitLab, Azure repos, and so on. Bitbucket, whatever. The important thing is that this use of source control platforms allows for version history and better, as in better tracking of the changes done during development. And tracking who did what and why. And in most platforms, if you're using the same vendor, let's call it that, both for your task management and for your source control, oftentimes you could connect the two, as in your source control, you would have something that is linked to a work item. And at the work item, once this link is created, you would also see this indication at the work item. This is, for example, possible in GitHub. You have GitHub issues, which interconnect with commits in GitHub. Same thing with Jira and Bitbucket, and same thing with Azure DevOps and Azure repos. There's a way to tag in a commit to tag a work item, and then you will see this bi-directional link. Also, source control, speaking of, allows for better collaboration of multiple individuals working on the same project, which would come into effect as, let's say, different branches working different developers would be working on different branches of the same source control repository, and they could work on different things, different work items without interfering or conflicting with each other. And if and when there is some kind of conflict, then basically every source control tool has built-in capabilities to resolve conflicts, basically. Let's say, okay, fine, we have source control, we have collaboration and work items. We would also expect to see some sort of QA testing, whether it's manual or automated tests or both, preferably both. And only when these tests are successful, that would indicate whether we can move forward in terms of deployments. Oh, hi, Blythe. um, and deployments, that's where I would expect to see different platforms, some kind of platform. There are different kinds, but I would expect to see some kind of CI/CD platform, and there's a very wide selection of those. We have Azure DevOps again. Sorry, we have GitLab, I think, or something that related to it. We have Jenkins, Travis, TeamCity, AWS Code Deploy, and Code Build. We have Octopus Deploy. Some of these are free, most of them are not. But it's also possible to have either an open source version of one of these. I think Jenkins, if I recall, is open source. But in some of those, they're also like a free plan. If you have a big team, then it makes sense to invest, in something that is enterprise level and paid. So this is the sort of set of tools or basic tools that I would expect to see in use at an organization, which I would then be willing to say, yeah, this organization has DevOps implemented as a methodology. Now, I'm going to take this infinite cycle here, and I'm going to simplify it a bit. And I'm going to show you what we would want to see as our end goal. So the capability of our organization that we would want to see is to have something like this process. We would have some developer doing some kind of development, regardless of whether it's application development or database development. Their developments be committed into some kind of source control. As a result, as a direct result, and direct and possibly immediate result of them committing the changes into source control, not necessarily commits, it could be also, let's say, merges or pushes or something like that, or maybe specific branches. But regardless, something that is immediately triggered by some kind of activity in source control would trigger an automated test of some kind. The very bare minimum that I would expect to see and hope that every organization implements is automated build tests, okay, as a bare minimum. Obviously, preferably, we would want to see something more, like, let's say, automated unit tests, or maybe even something more complicated than that. Regardless, we need to have something automated to make sure that we didn't break something, essentially. And then eventually, assuming that our tests, both automated and manual, if we have those, are successful, then it would move on to an automated, and there's an emphasis here on automated deployment to the actual environments, whether those are test environments, QA, staging, production, and so on. Okay, so this is the very basic process conceptually that we would want to see once we implement DevOps. And this is true, by the way, to any kind of DevOps, not necessarily database DevOps, any kind of DevOps. Why would we want to do that? So, or more specifically, why would we want this for database DevOps? So, if we have this for database DevOps, it would give us early error detection. And if we have early error detection, we would have fewer errors in production. If we have fewer errors, we would also have our deployments done faster, also because they are automated. And because they are automated, they will be more consistent and reliable, and as such, less prone to human error. As a result of these are the benefits at the technical level, but they also have direct impact on the business level. And that would come in the form of, first of all, faster time to market, less failures in production, better availability of your service. And since we are dealing with less errors and faster operations, we have less time wasted. And if we have faster time to market, that means more features and less time wasted on errors and troubleshooting and so on. That means we have more money earned. Less time wasted, more money earned. Okay? Don't take my word for it. There are surveys to prove me right on this, or rather, I'm telling you this because there are survey results on this. This is a graph from the latest state of the database landscape in 2024, survey done by Redgate, which essentially the main focus here is the top item here, answering the question, what are the main drivers for automating the delivery of database changes as part of a wider DevOps process? And the answer is to increase the speed of delivery of database changes. In other words, time to market. I'm saying this a lot this session. Time to market. There are also other top considerations or drivers for implementing database DevOps, such as faster speed and lower cost of each release, improved operational support, and faster deployment of fixes, higher quality products. All of this comes into this result essentially. Lower volume of defects or errors, improved frequency of new releases and delivery of features, and overall good processes across IT and development teams, including the automation. Okay. Talking about surveys, we're going to dive a bit deeper into a few more surveys. This one is from 2021, again from Redgate, about the state of database DevOps, talking about the adoption rates of DevOps for databases. Okay, so there's a clear trend here of an increase in adoption rates. For example, in 2017, 47% of the respondents adopted database DevOps either fully or partially. And in 2021, this figure almost doubled. 74% adopted database DevOps fully or partially. And obviously, the adoption rates only continue rising, especially this deep red section of which means fully adopted across all projects. Obviously, the trend continues rising. There's also a similar survey done by DB Maestro, not just Redgate, uh, asking similar questions. Specifically, do you think that a database should be an integral part of the DevOps process? Overwhelmingly, nearly everyone, 97%, say yes, the database should be an integral part of database DevOps. Despite this overwhelming agreement, and the desire to do so, only 23% of respondents have fully integrated the database into the DevOps pipeline to date. 62% have partial integration at some level, which is still a pretty high percent. And if we take it all together, 85% full or partial integration, that's a crazy high number, right? That basically means the race is on. Okay, you are not alone here. You would not be the first. You will not be the last to adopt database DevOps. Many organizations are already doing it, and they're reaping the benefits, basically. And on that note that no matter how fast they go, everybody's trying to run faster. Okay, across teams, accelerating release cycles is the top goal. In other words, time to market. And the speed of releases has accelerated. From these respondents of this DB Maestro survey, only 5 respondents are releasing a few times per year. Nearly half, 44%, are releasing between once a quarter and once a month, and 42% release between once a month and less and a few times per week. Sorry. Less than 5%, top performance, they do several releases per day, which is pretty crazy. Um, so DevOps culture in general has been highly focused on code and, let's say, infrastructure, specifically, especially with the advent of cloud till now, usually setting aside the critical component, sorry, of database. And the database in a lot of organizations still remains to be the last DevOps frontier, if you could call it that, that still has a tremendous potential to further accelerate the performance basically of the organization in terms of delivery, time to market, and so on. The database is naturally still a critical component, and if it holds everyone back, you're not fully there. Another very interesting metric is the question, how much DBA time is spent on manual, focus here on manual database releases. So based on this survey, most DBAs still spend most of their time servicing manual database changes. Nearly half of DBAs spend up to half of their time working on manual database releases. 35% spend as much as 75% of their time on manual releases, and 3% of poor DBAs, bless their poor hearts, spend 100% of their working hours working on manual database releases, which is pretty crazy. These numbers, they could be an indication of some kind of widespread, let's say, ineffective implementation of DB DevOps, although at least in some organization, I would imagine, it could also mean that the definition of what a DBA's responsibility is has possibly become leaner. Okay, that's also possible. Another interesting metric, potentially in that same regard, that could be what is impacting the previous metric. The question, what would you consider to be the top 3 reasons for errors when making changes to the databases? I'm not going to go into these items that were selected here, but I would say that you should pay attention that all of these items, all of these answers are at some capacity the result of either ineffective implementation of database DevOps or no implementation of database DevOps at all. Every single one of these answers. Okay, that's the main takeaway from this. Okay, so hopefully I convinced you that yeah, database DevOps is very good, but now the question is, how much would that cost me? Well, there is like a basic conceptual way to calculate return of investment on anything, which takes into consideration how many hours we are saving, what is the cost of each hour saved, and what is the cost of implementing whatever it is that we want to implement, let's say database DevOps. So the results of such a calculation are not always obviously apparent. Luckily, we have survey results of people, or rather organizations, that already implemented database DevOps and we could take their word for their ROI. So again, we're going to look at surveys done by both Redgate and DB Maestro with some very interesting numbers. So according to Redgate survey, these are all averages, by the way, averages across multiple organizations. The percentage of downtime out of all the downtimes at the organization level. So the 25% of those downtimes is caused by the database, which is quite a lot. The average cost of a downtime per year for enterprises is around $16.2 million per year. 25% of that is around $4 million per year. The cost of downtime from, let's say, suboptimal database practices. Similar numbers from DB Maestro, reaching around 3 million, the total cost of downtime per year for the database failures. Redgate also measured how much an organization saves once they implement database DevOps effectively. And their measurement shows 7 times lower change failure rate, as in, but it cuts down the database failures by 7 times. As a result of proper and effective deployments, basically, change management. So this means we are saving around $3.5 million per year. That's a lot. Not just the downtime is what is impacted by implementing proper database DevOps. We also have gains through release automation, just from the very fact that we are not doing things manually. Now there's something that is doing this automatically, and the people themselves can now use the time more effectively, more productively for other things. So according to the survey done by DB Maestro, these gains amount to around more than $500,000 per year. And this is for an 80% gain through automation. And Redgate measured 61% average time saved, which amounts to around almost $2 million per year. So even much higher. That's not all. We also have productivity gains from just, the database or developers in general working smarter, working more effectively, more productively. As an example, from the very fact that they're starting to work with source control, and that contributes to better collaboration. So DB Maestro measured around, again, $500,000 per year for productivity and efficiency gains. That's about 15% productivity gain. Redgate measured twice than that. They measured around a third, as in 33% of, on average, productivity gain, which if I do the same calculation on these numbers, these base numbers from DB Maestro, I reach around $1.25 million per year from productivity gains. In total, based on the DB Maestro survey, we have 4.2 million saved per year, and based on Redgate, more than 5 million per year. Now, these numbers, there's an interesting gap here, and there's a reason for this gap. The reason is that the DB Maestro survey was done on 2016. These are numbers from 2016. The Redgate survey was done just this last year, in 2024. So the recent increase, you could attribute it to maybe inflation, or I don't know, maybe something else, cost of and work hours or whatever it is. But there's definitely a trend here. Okay, so these savings, they only keep rising. Okay, so hopefully I convinced you that database DevOps is great and is the right thing to do, and it also saves you a lot of money, at least in the long term. Despite that, there are still challenges, and releasing database changes is hard. If I compare it to, let's say, applications, programming, development, releases, so in that case, it's simpler because we could override stuff. We could override configurations. We could reinstall the application from scratch, replace files, and just shut it down, bring it back up with a new version, and that's it. If we want to revert something, we do the same thing. We replace files, bring it down, bring it back up, and that's it. In databases, however, it's not as easy. We have data in databases, not just any data. We have QA data, we have data in development, we have data in production. And when we deploy changes to the database, we often work with something that we could call delta scripts, also known as change scripts or incremental scripts, that have to make changes incrementally in order to not cause data loss. In that regard, there are two approaches to database deployments. We have, in theory, state-based deployments, and we have migration-based deployments. It's two, let's say, competing, not necessarily mutually exclusive methods of deployment of database changes. Not going to go too deep into that because that is too technical. Just to let you know, I'm throwing these buzzwords out there just to let you know that it exists so that you would know what to look up after. And essentially, assuming that you implement either of these methodologies correctly, then essentially it just works, hopefully. Okay. Now, however, despite that, there are still all kinds of different challenges. For example, there could be um, configuration drifts. We could have someone performing a maintenance task, or some kind of performance optimization is implemented, or a different teams or developers' work overlaps with your own, and it causes all kinds of conflicts. And as a result, uh, let's say maybe a script that worked in one environment might not work in the next environment, or worse, it ends up creating damage and downtime and data loss. Um, Configuration drift is something that can present itself as, let's say, different schema configuration, different code, good code that was introduced by other teams, or plain production hotfixes, something was deployed directly to production rather than through the normal source control pipelines, let's say. And all of those implementation, all of that drift could be blown away by the SQL script that you are introducing, the change that you are introducing. Therefore, working with just a change script is effectively, let's say, a fate-based methodology, because all the stars must be aligned 100% for it to work. That's mostly relevant to migration-based deployment, but in a way, the same thing could also happen in state-based deployment, because that also could cause some kind of drift, some kind of change to be overridden. What do we do then? Well, the short answer is don't make changes directly in production. The long answer is we standardize. Or the longer version is we implement the database DevOps properly using several basic conceptual steps. These are example steps outlined by Redgate. And I'm going to dive in a bit into that and give some examples. So first step is standardization, which means we need to have standardized tooling. in place. And once we have that, we have precious time that is not wasted anymore on tedious reworking of changes. Sorry. Even a relatively easy innovation, like introducing a tool to standardize the way database code is developed and formatted, and let's say maybe even apply static code analysis as it is written, just that alone can reap big rewards. Once you use some kind of source control, then code becomes shareable. If you're using the right IDE, like let's say Visual Studio, VS Code, and so on, then errors in code are highlighted, immediately. And using the source control, developers can add or amend code written by other developers with ease. Um, and legacy code remains understandable code because you have version history and you are able to connect each change to a person, to a time, to hopefully a work item, and so on. Um, right. So this is step one, standardize the development work itself, preferably, or you know what? I'm not going to say preferably, must using some kind of source control tooling. Step number two is automation. Once we have source control, we can use that as a jumping board, essentially, as a trigger mechanism for automation. And we can use that automation to validate and test code using some kind of continuous integration process. Um, and let's see. Oh, okay. And these, I mentioned it earlier. There's all kinds of platforms that allow you to do that. Azure DevOps, Jenkins, TeamCity, Octopus. We also have database-specific platforms and tooling. For example, we have, I think it's ReadyRoll from Redgate, Liquibase, and DB Maestro also has some tooling, and some other vendors also have their own tooling. Um, just as a small side note, out of these, the only tooling that is specific to, let's say, SQL Server and free is SSDT from Microsoft, and it integrates fully with Azure DevOps. Okay, with other platforms, it might be a bit more difficult, not impossible. Right. So now, once we have automation, then we have reliable, scalable, and repeatable processes in place for building, testing, and releasing changes. And once we have that, companies can also implement security best practices and get data protection by design, which means, for example, we decide collectively as an organization all database changes must go through automated pipelines only, and everyone loses their admin privileges on the database so that they would not be able to do those changes, such changes directly on the database. Right? As an example. Also, important concept here is called something called build once, deploy many, as in the automation needs to work in a way that you have the build phase as a pipeline on its own, as a automation on its own. This will create something that is called an artifact, and that artifact will be used across all environments to as a source of truth to be deployed from. Okay, so we would use that artifact to deploy the changes to each environment, and I'm going to go into a bit deeper into that later in the later slide. So I'm going to skip ahead. Monitoring is also very important. Once you have an environment working and so on, especially production environment, it's very important to uh, uh, keep an eye on it to make sure it works okay, that there is no degradation of availability or performance and so on. And there's all kinds of tools for that, from SolarWinds, from Redgate, Quest, Aimbetter, Idera, and so on. There's all kinds of very, very good tools that I don't care which one you use, just use something to have a grasp on your database and what is happening there. The next phase after that, in many cases, this is an extra step. But the fourth step, called protect and preserve data, this refers to basically um, uh, test data provisioning. Okay, so this talks about the topic of, let's say you have developers and they need their own local copy of the database so that they would be able to do their developments locally without impacting the production. So there's all kinds of tools for that as well, from Redgate, from Dataprof, Delphix, DevArt. All these usually cost a lot of money, but there's also an open source free variant in PowerShell in the form of PowerShell modules from modules called DBA Clone and DBA Tools. Those offer a very good set of commandlets to operate and to create basically an automation of um, test data provisioning, basically. All in all, the end result would look something like this. I'm gonna go quickly over that because we are short on time. So you would have development environments in plural, specifically, hopefully, a development environment per developer, per person, not shared development environments, okay? Shared development environment is an anti-pattern, and shame on you if you do that. But local development environments is the way to go if you can afford to implement that. From that development, we store or commit the changes, into some kind of source control. From the source control, we have continuous integration pipeline. That's basically the build pipeline, build automation, what creates the artifact. This artifact will go then through the release pipeline and be deployed to testing and QA and staging and production and so on. And again, I remind you the concept of build once, deploy many. And this I would emphasize the importance of this because what I would not want you to do is, for example, let's say you deployed a version, committed a version, and created an artifact. That artifact was deployed to, let's say, a testing environment. As a result of the testing environment, some kind of fault was detected and now needs to be fixed, some kind of bug. I would not expect you to see something like fixing that bug in the testing environment and then continuing to move forward in the next environments. As in, we basically made a change between the testing environment, let's say the QA environment, and then we created a new artifact in the middle of our release pipeline. This is very bad. It's an anti-pattern. Because the same thing could also happen, let's say, between QA and staging, or between staging and production. Some kind of fixes that we do during that stage when we detect some kind of bug. But if we do that and just keep moving forward in the pipeline, we might be missing something that was not tested in the lower environment. Okay, let's say, for example, we did some kind of fix in staging and we deployed it directly to production. This change that we made was not tested in the test environment, in the QA environment. Okay, so the right way to do it is to go all the way back. And the change, this fix that I'm doing it, I'm going to do it here in the source control. All right, I'm doing development, deploying it to committing it to source control, and then the whole cycle starts from the beginning. I'm creating a new artifact and I'm testing everything, the whole thing. testing, QA, staging, production, whichever environment phases you have. Okay. From that production environment, we would also have some kind of monitoring, obviously, and from that we would also be creating some kind of backups of production normally, and from that backups would also have some kind of provisioning and masking operations maybe, and from these operations we would be able to provide the local development environments. This is basically the complete picture. Okay. Now, many people, they might be missing this bottom half here, specifically of the provisioning, because it is a challenge to implement. Not impossible, but it is a challenge. Um, but basically, this top section is the critical one in truth. Okay. All right. So let's say, thank you, Eitan, you convinced me, but it's not enough because now I need to go and convince others. Let's talk a bit about that. So in order to implement a change of this magnitude in an organization, there's a method for it. It's called leadership alignment. What does it mean? What does it mean? It means that we need to have motivation from both uh, ends of the hierarchy in the organization, both from the developers, where they would experience the most gains from it in terms of productivity and efficiency. All right, they would not be um, uh, um, having to deal with troubleshooting errors, dealing with change management deployments, manual deployments, and so on. Their time would be more productive working on more impactful changes. So that will be their gain. And we would also need motivation coming from the management level, whose main focus would naturally be on profitability. When the developers work productively and efficiently, the organization naturally experiences better profits. In the middle, we have a critical missing component here. And this critical component is something that is called a sponsor or a group of sponsors. And their job is to mediate between these two layers. Their job is to speak directly to the developers, get feedback from them on how things are going and what are the challenges, and also communicate with the management level and communicate their goals and vision and high level directives to the developers themselves doing the actual work. These sponsors, they would be the main drivers, the main, let's say, pushers of the implementation of this new methodology. Okay. Usually these sponsors, those are you. Okay. And what I mean by that, these are people, let's call it, I guess you could call it mid-level management. People like CTOs, CIOs, team leaders, product managers, and so on. People like that. That's the sort of people that I'm talking about when I'm talking about sponsors. So it's their job to, first of all, be themselves motivated to do it, but also be the ones to motivate the other people in the organizations to move this forward. If you don't have management on board, there is no way you will be able to implement this, because implementing database DevOps is a huge change in an organization level methodologies of work. If you don't have management on board, there is no chance you'll be able to do it. Okay. But also, obviously, you need the developers also on board. Although, if you have management on board, theoretically, you could force them to also be on board. Okay. It doesn't work the other way. usually. But your job as a sponsor, as a mid-level management person, that's the sort of people that can make this change and convince management. Okay. Now, in case you missed it, in case you did not get the message yet, if you're not racing, you're already losing. There's a race going on. It has been going on for decades. And if you're not there, you're already, losing. You're falling back. So you better, get on it. And this is, as I said in the beginning, this is an introductory session to the topic. I have a whole series of on this topic, specifically focusing on database DevOps, and even more focusing on SSDT. And you can check out my series. There's recordings, and you can keep track of it. If let's say I have a new session coming up and so on, you can use the link shown on the screen. Speaking of links, I would also encourage you to check out some additional interesting resources. We have the chat here, right? So I'm going to paste these links into the chat in a moment. There are all kinds of articles on this topic that I will strongly recommend you to check out. There's also a very, very good session by Alex Yates titled Zero Downtime Database Deployment. I always recommend it. It is a very high level strategic sort of session. It doesn't necessitate focus on a specific RDBMS or a specific tool. It's very, very high level and conceptual and strategic. But if you do want to go to be more specific, there's also the Azure DevOps Duet by Kevin Chand and Sandra Stad, which is focused specifically on SSDT and Azure DevOps. And speaking of SSDT, you could also check out the official Microsoft Learn website with some guidelines under the article Project-Oriented Offline Database Development. And if you want to delve a bit more into the business side of things, you can also check out a case study with ROI included, done by Redgate of an insurance company, streamlining database deployment using Redgate tooling. As I said, I'm going to paste the links in the chat in a moment. And I think that's basically the time we have.